Good afternoon, Chemistry B students. Just want to go over some things that you've been working on so everyone is comfortable with what they're doing. We will not be on Zoom, obviously, on today on Wednesday, but I want to give you guys just sort of an overview of things that you've been doing. Yesterday, most of you started on the band of stability worksheet, an isotope worksheet that looks something like this. In that top section there, we're asking you to simply find the protons, neutrons, and electrons. The first one has been done for you. This is in the nuclide. What we call these are nuclides. So if you see a 24 at the top, and then you see the magnesium, and then you see the 12 indicates the atomic number, the 24 indicates the mass number. And so that's nuclide formation. When we start doing nuclear equations, which we may start tomorrow, you're going to be noticing that form quite a bit. So it's good to get comfortable with that to understand how to read those. So you go ahead and fill that top section out. Most of you probably did and had no problems with that. But then we have to see if whether or not these particular atoms are stable. And so that's where we switch over to the band of stability um, we're drawing, Google Drawing, which is here, which can be a little challenging to do. Magnesium's already been done for you, but let me show you how we did that magnesium. So if I go down here to that nuclide, which is the magnesium one, I know that the protons are 12. And so what I do is I basically look at the bottom of this graph and I see that that proton has protons at the bottom. So if I go over 12, which is just a little, just a little ways there, and then I go up to the number of neutrons. How do I solve that? Well, I know that that 24 minus 12 would be 12 neutrons. So this is pretty much easy to then see that I'm also going up 12 as well. And that's where that line would fall. So that line for that particular magnesium there, as you can see, is right there where 12 and 12 are crossing. Again, 12 protons, which is given. The neutrons, I got to subtract that mass number from the protons to do that. So these over here are the ones that you got to solve. So for example, iridium 77, I know that iridium 77 would be right around here in terms of the proton number. And then that 191 minus 77. So if I take a calculator and I take 191 and I subtract 77, I get 114. So that means I got to come up to 114, which is up here. And would be, yeah, right in that area right there. So it looks like that iridium would be in the band of stability in this case. And so that's where that would fall. So if I wanted to do that, then I would just simply move this over here. And then I would simply take and create a line from that iridium to that band of stability here. And again, if you want to make that line red, you can to make it stand out. So you can see that one there, make it a little thicker. There you go. And so that's how you would do that one there. So that's an example of how we move these things around and what we do. And so you just simply, again, take that mass number, subtract those protons, and that will give you the number of neutrons. And that's where you can find that going up that y-axis. So that's what we do with that. So again, that's how you do those. One's already been done for you, but I just showed you how to do the iridium one as well. So go ahead and get those positioned on the graph. Some of them may be on the band of stability where they're stable and they're not going to really decay. And then others would be unstable. So it's good just to know where they would fall. So that's that document there. And then there's a corresponding document that goes with it. All right, so for today, once you finish that, what you're going to do is you're going to go to today's assignment, which is what is radiation? And so that what is radiation assignment is basically a Google slideshow. It's not due until tomorrow by the end of class. You will have time tomorrow to work on it in class, but let's see how much you can get done today. And if we open that up, you're going to see quite a few slides here that are going to have some directions on each slide for what you need to do. It's a manipulative, and so you can just simply go to each slide and then there's little videos that are embedded, and then you just have to type in what your answer is. And after you watch that, and you just complete this particular slide here. So that's what you're going to be working on today. See how many you can get done in the amount of time that you have for this class, and which is only a half hour. So if you can get like half of it done, that'd be awesome. And then if you want to work on other things, you can, just to get ready for tomorrow. Tomorrow we'll discuss everything we've gone over this week. We'll have a review. We'll definitely be on Zoom tomorrow. Get you ready for that quiz on Friday. and hopefully get us going on nuclear equations and looking at those and then seeing how those apply to that red cup phenomenon and why is that cup radioactive. All right then. So make sure you fill out today's attendance form. It's just a simple form. You just type your name and that way I get attendance taken for you guys today. And then you have the hour to work on your radiation slide. And if you have to fix those band of stability drawings, you can do those. And then you're all set for tomorrow. And then tomorrow, like I said, we'll finish these slides and we'll be doing some review. All right then. Have a great day, everyone, and go Bulldogs.